Okay, now we're going to talk about taking the cube of a binomial. And remember that when you cube something, it's just like writing it 3 times. Or it could be a minus sign in between. But when you go to do these ones by hand, which is right here, right? The parentheses 3 times and distribute, you can only do 2 at a time. From a previous lesson, we discussed this. So let me go ahead and show you that. And then at the end, I'm going to show you Pascal's triangle, which I'm going to teach now because you're going to be taught it again, I think, in Algebra 2C when you start taking things to the 4th power and 5th power and 6th power. All right, so this is one way to do this. I don't do mine this way because I know Pascal's triangle like the back of my hand, but this is one way, okay? The reason I also don't do this, besides Pascal's triangle, is because it's a lot of work and a lot of chances to make a mistake. All right, so x times x. X times -5. -5 times x. -5 times -5. Okay, we add up our like terms here. And now you could have used the shortcut we discussed in the last video to do these two to come up with that right away. So you didn't have to do this in between step. But now we're going to take this third parenthesis and bring it down. And now we're going to distribute this x squared by everything over here. X cubed and then -5x squared. Now we're going to take this -10x and distribute it to everything here. So we get -10x squared and then a +50x. And now we're going to distribute here and we get 25x. And then I distribute here, again, somebody might make a mistake, but it's -125. All right. Now let's go through and add up all our like terms. There's only one cube, so we're going to write that down. Add up these squareds. Okay. Add up these regular x to the first powers. And then bring down the n number. Whew. Look at that. Now what I'm going to do is, again, this is the way that you were taught earlier, but there's a shortcut when it comes to a binomial being raised to a power, and it's called Pascal's Triangle. So let me talk about that in the next slide. We're going to do the same problem. All right, Pascal's Triangle is a guy who developed a triangular method to help us do the work here without really doing the work. Okay, so a couple things you need to know about Pascal's Triangle. The numbers are going to be aligned in a triangular format. Okay. There's always ones diagonally going down either way. Okay, the first row has one number. The second row has 2 numbers. Okay, the next row has 3 numbers. And the next one's going to have 4 numbers, etc., etc. So that row is supposed to have 1 number. It already has 1 number. That one's done. This row is supposed to have 2 numbers. It already has 2 numbers in it. We're done. This row is supposed to have 3 numbers. And it's got 1 here and 1 here. But we're kind of missing this middle term. So how do I get it? Well, what you're going to do is you're going to add the 2 numbers up above it. So if you add up 1 plus 1, I will get 2. Okay. The next row is supposed to have 4 numbers. But there's only 2. So I'm missing a number here and I'm missing a number here. So to get this number, I'm going to add up the 2 right up above it. So 2 and 1 added up is 3. 2 and 1 added up is 3. And that's as far as you need to go with a triangle right now. Because what's going to happen is you're going to look at this outside exponent. Okay, and ignoring the ones, remember, ones are always there. Ignoring the ones, you got to figure out what number has a 3. So it's like the second number in is what you're looking at. So we're going to use this row for Pascal's triangle. All right, so what we're going to do is these are called our coefficients. And I do the work up and down. You can do it across if you want. It's just when you go across, you don't know how much room to leave yourself. All right, so I'll go 1, 3, 3, 1. These numbers come from the triangle. All right, now put parentheses. You need to get in the habit of parentheses here. Okay, you're going to take your first term here, x, put it inside the parenthesis. You're going to take this exponent, 3, put it in the top, and work your way down. You're going to take the second term, now notice that's a negative 5, put it inside this parenthesis. You notice how this exponent went 3 down? Well, now you're going to go at 0 and go up to 3. And you should always have the correct numbers here because it's based on this exponent. And now we're going to go through and we're going to simplify our problem. Okay? First of all, what's anything raised to the 0 power? The number 1. So I'm going to put times 1 there. This x to the 0 power really means times a big fat 1. 1 times x to the third from right here times 1. Okay? This one's going to be 3 times, this here means x squared. And negative 5 to the first is negative 5. Okay, next one is 3 from here. X to the first is just like this. Negative 5 squared is 25. This one's going to be 1. That x is gone. Remember, it's just 1. Negative 5 to the third is negative 125. Now we're going to put it all together for a polynomial. So what is 1 times x to the third? It is x to the third. 3 times negative 5, I almost said the answer, is going to be negative 15, and then there's an x squared here, right? 3 times 25 is 75, and then there's an x to the first there. And then 1 times negative 125 same answer, different method. All right, we're going to try one more. The reason I want to try one more either way is because the first one, doing it by hand, wasn't that big of a deal. But when you start throwing in extra exponents or variables, doing it by hand gets very cumbersome. Pascal's triangle, I need a 3 there, right? So it goes 1, 1, 1, 1, 1, 1, 1, right? One number, 2 numbers. We're missing a number here. To get that missing number, it's right here. Add those up. And we're missing a number here and here. So add those up and add those up. If you kind of get in the habit of anytime there's a cube, you're always going to use these numbers. 1, 3, 3, 1. Okay. So I'm going to write 1, 3, 3, 1. Okay. In parentheses all the way down. And parentheses all the way down. Get parentheses for both your terms. Now take this first term, 2x. Put it here, and here, and here, and here. Okay, start with this exponent, 3, and work your way down. For the second one, we take our second term, positive 5y. And now instead of going 3, 2, 1, 0, we go 0, 1, 2, 3. Okay. Now anything in parentheses raised to the 0 power is technically the number 1, but we don't really even need to write the number 1 because it's unnecessary. So now we're going to distribute, and we're going to simplify and be done. We're going to start off with a 1 here. Okay, now remember, this goes back to a previous chapter now. When you have parentheses inside and there's an outside exponent, it goes to each piece. So 2 to the third is 8. X to the third is x to the third. Okay, let's move on. Let's look at this row. 3. Okay, 2 squared is 4. And then x squared is x squared. Same thing here. 5 to the first power is 5. Y to the first power is y. Next row. Okay, start with 3. 2 to the first is 2. X to the first is x. Okay, 5 squared y squared. And moving on, we have this 1 here. Remember, that was really just 1. Times 5 to the third. And y to the third. And now let's put it all together. What's 1 times 8? Thank you. 8. Okay, now over here. We have 3 times 4, which is 12. 12 times 5. And then we just throw our variables at the end. Okay, over here, we have 3 times 2, which is 6. 6 times 25. And then, of course, we've got our variables, x and then y squared. Notice that these are different. This has an x squared, that one has the y squared. And then here, 1 times 125. There you go, we're done. And then before I go on and do the same problem again, doing it the longer way, I just want to make a note of this. When there's a plus sign in the original problem, you're going to have all plus signs. Okay, if there's a minus sign in the problem, your first one's going to be a plus, and then it's going to be minus, and then plus, and then minus. It's going to alternate. Let's do the same problem again, but let's do this one now the longer method. All right, so I need to do 2x plus 5y 3 different times. I'm going to distribute 2 times 2. Make sure you've got the squared there. There's a lot of chances to make mistakes doing it this way. 2x times 5y. Okay, distribute here. And distribute 5 times 5. And then y times y. Now we're going to add up our like terms. Now we're done with this, but we're going to add up our like terms. Again, make sure not to make a mistake here. 20 xy, the variables don't change. Okay, now the third parenthesis we're going to bring down. Alrighty. Now I got to distribute again. I'm going to have to write a little bit smaller because I'm running out of room. 4x squared times 2x is 8x cubed. Alright. 4x times 5y is 20x squared y. And we're done with that one. Now let's distribute the middle term by everything over here. All right, 20xy times 2x. So 20 times 2 is 40. X times x is x squared, and then you've still got a y there. All right, 20 times 5 is 100. X, we have a y times a y. Now we're going to distribute here. 25 times 2 is 50. Y squared and x. So I'm going to write the x first and y squared second. I always go alphabetical. Okay, and then we've got to distribute here. So 25 times 5, y squared times y to the first would be y to the third. And now we have to go through and add up our like terms. So that'll give me 8x cubed. Okay, these are like terms. Add the numbers in front only. Leave the exponents alone. Okay, these are like terms. Same reasoning as the last one. And then bring this down.